All right. Good afternoon. Okay, so the first thing I want to talk about is the final for Honors Algebra 2. And it's going to be for this period, period 3. It's on Thursday, June 3rd, and it's 2 hours, 9:25 to 11:25. So that's 120 minutes. All right, so the final would be 40 questions. And so that's approximately 3 minutes per question. So obviously, some questions won't even take 30 seconds. Some questions might take 5 minutes, but on average, you're thinking 40 questions, 120 minutes, 3 minutes a question. All right. The next thing is that your scratch paper will be due after that. So I'm going to give you 30 minutes to turn in the scratch paper. So that means the scratch paper will be due at 11:55. If you do not turn in your scratch paper, you will get a 0 for the final. If you turn it in late, you'll be docked 10 points straight off the top of the final. So the scratch paper is going to be important. Make sure you turn it in on time. After the 120 minutes, you have 30 minutes to turn in the scratch paper. Okay, so once again, if you don't turn in the scratch paper, you will get a 0. If you turn it in late, you'll get docked 10 points off the top of the final. All right, so over the weekend, because I had some students asking me about what's on the final, I sent you the the lessons. So I decided that not only am I going to give you the lessons, I'm going to give you the problems that are going to be like the final. And no teacher will ever do this. I will never probably do it again in the future, but because of the distance learning and everything else, and one of my friends that said, yeah, go ahead and give them the problems. These are not the exact problems. These are problems like the ones on the final. So, all right. So the first thing I'm going to do is, and I'm not going to write it on the board because everybody who's absent right now, they're not going to get this. So it'll be up to them to hunt it down, or if they hear about it through the grapevine or whatever, I'm not writing it down. So let me give you the lessons that we covered in second semester first. So write these down. You ready? If you're on Remind and you got the Remind message, you got them already. It's lesson 8.1, 9.3, 10.1, 10.2, 10.3, 11.1, 11.2, 11.3, 12.1, 12.2, 12.3, 13.1, 13.2, and 13.3, 15.1, 15.2, 16.1, and 16.2. So that's 18 sections. So you can count on 2 problems per lesson. Some of the lessons have 3 problems. All right, so anyhow, now I'm going to give you the problems that are like the ones you'll see on the final. Okay, in 8.1, you should know how to do 9 and 17. In 9.3, you should know how to do 4 and 17. In 10.1, you should know how to do 1, 7, and 13. In 10.2, you should know how to do 2 and 10. In 10.3, you should know how to do 5 and 12. In 11.1, 1 and 11. 11.2, 7 and 15. In 11.3, 1, 6, and 19. 12.1, you should know how to do 4 and 9. 12.2, 5 and 8. 12.3, 3 and 9. 13.1, 2 and 11. 13.2, 3, 6 and 9. 13.3, 8 and 12. 15.1, 5, 9 and 20. 15.2, 3 and 5. 16.1, 1 and 17, and 16.2, 6 and 12. All right, anybody want any of those repeated?
Miss Fritz, what were the sections again? There was 8.1, 9.3, 10.1, 10.2, 10.3, 11.2, 11.3.
11.1.
Okay. What were the problems in 11.1?
1 and 11.
And then I have 11.3, 12.1.
11.2.
Okay, I have that one. 12.2, 12.3.
12.1.
I have that one. 13.1, 13.2, 13.3. And what were the problems for 13.3?
8 and 12.
And then I have 15.2. And
15.1.
what were the problems?
5, 9, and 20.
And then for 15.2?
3 and 5.
Okay. And then it goes all the way to 18, right?
16.1 and 16.2.
And what were the problems for 16.1 and 16.2?
16.1 was 1 and 17, and 16.2 is 6 and 12.
Okay, thank you.
Anybody else need anything repeated?
What were the problems for 9.3?
4 and 17.
Okay, thank you.
Okay, anybody have any questions about the day of the final, the time of the final, or the scratch paper? All right, well, I never really understood why they did this, but after, well, you know, we have no school on the 31st. That's Memorial Day. And then you have finals on Tuesday, Wednesday, Thursday, and then we come back to school on Friday. Now, the big question is, what do we do when we come back to school after we've taken the final? And I can't answer that because I have no idea. Okay, I know what I'm doing. I'm doing the grades. So what I decided to do is, so I can take attendance, is I decided to have you guys write a reflection paper, and I already posted it. So if you want to do it earlier, you can do that. But here's the catch. You have to turn it in on Friday. So you have to check in. You will not come to WebEx at all. Like I said, I'm doing great. So you will not come to a WebEx meeting, but you have to turn in your reflection paper on Friday, June 4th. Do not turn it in earlier, or you will be marked absent. So if you come into work, if you want to work on it, you know, during class, that's fine. But we're not having a WebEx meeting. I'm doing grades. But you have to turn it in on Friday, June 4th. All right, so let's look at it real quick. Let's see if I can find it. Darn it. It's like underneath this stuff. Let me do it. All right. Okay, so basically, I'm not putting any, I'm not saying anything about how long it needs to be. So it could be 20 pages, it could be 10 pages, it could be 5 pages, it could be 1 page. I don't care. I mainly just want to, I want you to just be thoughtful about it. This is an end of the year reflection paper. This assignment is to be done individually. You're going to create a Google Doc and respond to one of these questions, just one. Make your paper as clear and concise as possible, and it's okay to be honest. The first question that you can choose from is, how did you grow as a math student this past year? Think about what you learned about yourself, your skills, your study habits, your knowledge, your mindset, etc. Number 2, what advice would you give to students who will be in this class next year? And then 3, knowing what you know about this class, if you could write a letter to yourself that would travel back so that you'd receive it at the start of the school year, what advice would you give your younger self? So like I said, you only need to respond to one of these. And I don't care how long it is. I just want you to be thoughtful. And like I said, I posted it so that if you want to work on it, at your leisure, that's fine. Just make sure you turn it in on the 4th because I'm going to use it to take attendance. All right. Any questions about the reflection paper? All right. Hopefully it'll be easy. I did not create this to burden you or to have you, tax your brain. I hope it's just something that you can just write from your heart and that'll be it. All right, the next thing let me stop sharing. The next thing I want to do is I want to give you the answers for the unit circle. I called it a quiz, but it's not. I want to give you the answers for that. And I want you to grade your paper and then basically self-assess, did you get it or not? So it's this one. All right. So this is normally what I do in class. I'll either give you the answers on the Elmo, or I will say the answers out loud. Distance learning was a little bit different because I really hated it because I couldn't really check your work that good, but I do check work. I make sure that's why I'm really hoping all of you really listened to me and tried to do what I modeled on the board, because I'm going to be real strict about your notation in honors pre-cal. So just have to make sure that you can work through a process from beginning to end and be clear about what you're doing. So, all right, number 1 was 0 degrees, 0 radians, and the point was right 1, 0. Number 2, 30 degrees, pi over 6 radians, and the point was radical 3 over 2 and 1/2. Number 3 was 45 degrees, pi over 4 radians, radical 2 over 2 and radical 2 over 2 was the point. Number 4 is 60 degrees, pi over 3 radians, and the point was 1/2 and radical 3 over 2. Number 5 was 90 degrees, pi over 2 radians, and the point was 0 up 1. Okay, the next page, basically there wasn't a whole lot of work to show except for tangent. You might want to have shown the complex fraction, but this page, these were evaluating the basic trig functions for reference angles. So basically you could just use your left hand and there is no work to show. All right, number 6 was square root of 3 over 2. Oh, by the way, all these answers should be positive because remember, reference angles are always positive acute angles in the first quadrant. So number 6 was square root of 3 over 2. Number 7, radical 2 over 2. Number 8, radical 3. Number 9, 0. Number 10, 1/2. Number 11, 0. Number 12, 1/2. Number 13, 1. And 14 was radical 3 over 3. Make sure that you don't leave a radical in the denominator of a fraction. We're still simplifying radicals. Okay, on the next page, I showed you a three-step method, but when you get really good at this, you're not going to be using the 3 steps. It's just going to like come, like breathing or walking. So I'm going to give you the 3 steps. Okay. Okay. Number 1, the reference angle was 60 degrees. Number 2 was 1/2. And the answer was in quadrant 4, 1/2. Number 16, the reference angle was pi over 4. The second step was radical 2 over 2, and the answer was radical 2 over 2. Number 17, the reference angle was pi over 4. When you have number 2, when you evaluate tangent of pi over 4, you get 1, and the answer, number 3, step 3 was -1 because it was in quadrant 4. Number 18, the reference angle was 30 degrees. Cosine of 30 degrees in step 2 is radical 3 over 2. And cosine of 210 because the angles in quadrant 3 was negative, radical 3/2. Number 19, number 1, the reference angle was pi/3. Number 2, the sine of pi/3 was radical 3/2. And number 3, the angle was in quadrant 3, so the answer was negative, radical 3/2. And then number 20, the reference angle was 30 degrees. Step 2 should have been radical 3/3. And step 3, the angle was in quadrant 2. The answer should have been negative, radical 3/3. All right, anyone want me to work a problem? Now, when I give this quiz in class, students have to get a 90% or higher. If they don't get a 90% or higher, they're not allowed to take the exam. So they have to keep coming in and with tutoring with me, they can't take the exam because there's no point. There's no point taking the exam for this chapter if they don't know this. So they have to get a 90% or higher. So kind of just look at yourself, did you get a 90% or higher out of 20? If you did, then you're good to go. If you're not, then this is something you're going to have to get when we start the pre-calculus course. Anybody want me to work a problem? All right, I'm going to finish. If you notice, I did not put any problems on the exam for 17.1, 17.2. What I'm doing is I'm transitioning you into pre-cal. And so these are like the most important things. So I'm going to finish 17.2. And I think I posted the lesson for 17.2. So looking at the calendar, the unit circle, what we just went over, is due tomorrow night. And lesson 17.2 from the book, that's due on Friday night. All right, so I'm going to try to finish 17.2. We evaluated trig functions of sine, cosine, and tangent. This is the second objective, evaluating. So what happens when you have an angle that's not a special angle? What if it's not 30 degrees? What if it's not pi/4? What if it's not pi/6? What if it's not 3 pi/2? What if it's some weird thing like cosine of 23 degrees? Sine of 1.7 pi? We're going to use a calculator. Now, one thing I didn't stress, and I really do want to stress this, when you're working in degrees, you have to be in degree mode. Now, on the calculator, remember the mode key is this black key, and you have to make sure that if you're in radian, if you're working with radians, make sure you're in radian mode. This is the most missed thing on this exam when I give it, is that students will be in degree mode and they meant to be in radians, or vice versa. So you have to make sure that if you're using a calculator, that you're in the correct mode. All right, so make a note of that. I'm also going to write it in the notes here. Evaluating means find a number. So evaluating the basic trigonometric functions using a calculator. Now, let me warn you, when you don't have to use a calculator, like that quiz, that paper we just did, don't use a calculator. You're only using a calculator when you're forced to. So in other words, in pre-cal, somebody's not muted. Can you check yourself real quick? In pre-cal, if you don't show the work for ones to do by hand, you don't get credit for them. So this first example, it tells you straight out to use a calculator. So use a calculator to evaluate. The trig function. Of the angle in degrees or radians. So what I was saying before is working with degrees. Put yourself in degree mode. Working with radians. Radian mode. And you might be wondering, why are you writing that on the board? We can remember that. There's a whole bunch of students that aren't going to remember that, and they're going to be getting all the wrong answers. So you've got to make sure you're in the right mode. All right. So here we go. So we want the cosine of 23 degrees. We want to make sure we're in degree mode. And all you do is you just hit cosine and put in 23 and it knows. So what do you get?
Question, for these ones, we don't have to put the degree sign, or should we
Yeah.
do? Okay,
No, you don't have to put the degree sign, it knows.
I got 0.920504.
It's about 0.92. What about tangent of 114 degrees? Got to make sure you're in degree mode.
I got negative 2.246.
It's about 2.25. It's about negative 2.25. And then what about sine of negative 237 degrees? About 0.839.
Yeah, that's what I got.
Okay, now remember what you're doing here. Remember what you're doing. These are the angles. And what you're doing is you're finding the x coordinate. It's about 9. The tangent y over x is about -2. And the y coordinate of the angle for the point is about 0.8. All right, now change your mode to radian mode. Now remember, if you don't see radians, you assume it's radians. So since we don't see degrees, this is radians. So what's the sine of 1.7 pi?
I got negative 0.809.
It's about negative 0.81. Cosine of 5 pi over 8. That's not degrees, so it is radians. So make sure you're in radian mode. What do you get for that one? Five times pi divided by 8.
I got negative 0.3826.
Mm-hmm. And the last one would be tangent of negative 7 pi over 11. That's about what?
I got 2.1896.
It's about 2.19. Okay, any questions about evaluating basic trig functions that can't be done by hand? All right. Well, we've only looked at the unit circle. So we've only looked at circles with a radius of 1. So now I'm going to extend it out to a radius of r. We're going to find the point on any circle. So let me show you this. All right, the trig ratios can be expanded to coordinates x, y of any point. So far, we've only looked at special angles and their points. But now I'm saying that we can expand this to find any point on a circle with radius r, not just a unit circle. So the trig ratios can be expanded to coordinates x, y of any point on a circle with radius r centered at the origin. Now, notice what this says. It can't be centered somewhere else. It's got to be centered at 0, 0. All right, and here's what they look like. The sine of theta now is equal to y over r. So we know that sine of the angle is y, but now to find it, we're going to say it's y over r. Cosine is x over r. And the reason why if you're wondering, why didn't she write cosine first? Like if cosine is x, excuse me, why didn't I write it first? Because tangent is defined as y over r, and it's easier, I'm sorry, y over x. It's easier to see it like that when you memorize them. X cannot be 0, by the way, because you can have a 0 in the denominator. So this all goes in a box. So the x and y coordinates of any point on a circular arc of radius r and angle theta are given by all right, here's your ordered pair. And this is what it looks like. It looks like r times cosine of theta, that's going to be the x coordinate. And r sine of theta is going to be the y coordinate. So this goes in a box. And that's how you're going to find an ordered pair. Just remember that r times cosine of theta is your x coordinate and r times sine of theta is your y coordinate. Now, theta, the angle can be in degrees or radians. Just depending on the problem. All right, so let's do some examples. All right, find a value or an expression for the coordinate on a circle centered at 0, 0, and at an angle theta from the x-axis. Okay, what does this problem look like? All right, so they're going to give you a radius, and in this case, it's not 1, it's going to be 6 something, and the angle is 124 degrees, and they want us to find the x-coordinate. So first of all, let's look at what they give us. They give us a radius of 6 something inches, I don't know. Theta is in degrees, and they want us to find the x-coordinate. All right, so we don't want to work with a calculator if we don't have to. So what we're going to do is find the reference angle. And you know how to do this. You go to the closest horizontal, which in this case is 180 degrees, and subtract off 124. So what's 180 minus 24? 124. $56 degrees. Well, guess what? This doesn't help us because we don't know about 56 without the calculator. Now we tried, but we can't do it. So let's make a little note here. This reference angle doesn't help. We need a calculator. So basically we tried, but we couldn't do it. Make sure your calculator's in the right mode again. You're all in degree mode, right?
Yes.
So we do not want to use a calculator if we don't have to. And so just remember that we always want exact answers, if possible, without a calculator. So in other words, let's say the answer is radical 3/2, and you used a calculator and came up with a decimal. Well, I'm not going to use a calculator to come up with the decimals, so I don't know if you're right or wrong, and I'm not going to grade it. So you have to come up with exact answers when possible. All right, so that didn't help. So what do we do now? Well, what we're going to do is we know we want to find x, and x is defined as r cosine of theta. So all we do is we take 6 and we take cosine of 124 degrees. And it doesn't matter that it's not a reference angle because we're going to use a calculator. So tell me, so you're gonna put this in the calculator. And how I would do it, I would put in cosine of 124 and hit enter, then multiply by 6. So this is a product. So what do you get when you put in cosine of 124 times 6?
I get negative 3.355.
It's about negative 3.36. We're going to do the same exact problem. I should say the same type of problem, different problem. So this is B. It's pretty easy, right?
Yeah.
So in this case, the radius is 2. The angle is 150 degrees. And they want us to find the y coordinate. So once again, we have to try it by hand and see what happens. So the reference angle would be, once again, the closest horizontal would be 180 degrees minus 150 is 30 degrees. And we definitely know about a 30-degree angle. So this time we don't pick up the calculator, and we're going to find y equals r sine of theta, which is going to be the radius, which is 2 times the sine of 30 degrees. Well, you know what the sine of 30 degrees is by looking at your hand. So what is the sine of 30 degrees?
The sine is 1/2.
Yeah, and so isn't this 2 times a half, which you can cancel the 2s, so y equals 1? And this does make sense because 150 degrees is in the second quadrant, where the signs are negative, positive. So you could check yourself by using common sense. You know the y coordinate. If the ordered pair is negative, positive, the y coordinate should be positive. Let's do another one. In this case, the radius is 3. The angle is 2.4 radians. And they want us to find the x coordinate. So once again, I'm going to try to find the reference angle. And so what's the, now that, this isn't 2.4 pi, that's 2 radians, it's 2 of those, and 4/10 of a radian. So what's the closest horizontal? What's the closest horizontal to 2.4 radians?
Would it be 180?
But we're using radians, so you're telling me pi? Pi? Yes, 3.14 minus 2.4.
Yes.
So what's that?
Yeah, it's about that.
Well, we don't know anything about that. Right? Do you guys know about a reference angle that's about 74 hundredths?
No.
I don't. So we're forced to use a calculator. So we have x is equal to r cosine of theta. So x is equal to the radius, which is 3 times cosine of 2.4 radians. Make sure you're in radian mode. And what is cosine of 2.4 radians times 3?
About negative 2.21.
Yeah, it's about negative 2.21. I'm going to do one more. This time the radius is 4 and the angle is 7 pi over 6 radians. So they write at that time. And they want us to find the y coordinate of the point that's associated to that angle with the radius of 4. And so we're going to find the reference angle. So if we draw a little picture, we know that this is 6 pi over 6. So we know 7 pi over 6 is down here, right? Yes. But the closest horizontal is 6 pi over 6. So we take 7 pi over 6 minus 6 pi over 6. And like I told you, it doesn't matter the order or anything. Just get a positive acute angle in the first quadrant. So what's the reference angle? Pi over 6 radians?
Yes.
All right. So now we take y equals r sine of theta. So the radius in this problem is 4 times sine of pi over 6. Well, we can do this by hand, right? What's the sine of pi over 6?
1/2.
1/2. So once again, we can cross cancel and get y equals 2. All right, now hold on just a second. We evaluated the reference angle. So if we evaluated the reference angle, don't we need to know what quadrant the actual angle's in? So if the actual angle's over here at negative, quadrant 3, shouldn't this answer be negative? I'm going to say that again. We found a reference angle to help us out. And if we evaluated a reference angle, don't we still have to put ourselves in the correct quadrant of the actual angle?
Yes.
And the actual angle is in quadrant 3. So the y value in quadrant 3 should be negative. So you might want to put a star by this one to make sure you don't mess up on the negatives. Now, when we use a calculator, you don't have to worry about that. But when we're doing things by hand, if remember, if we're ever evaluating the reference angle, you have to put yourself in the right quadrant of the terminal side of the actual angle. Okay, now, what we're going to do now is I'm going to do a Ferris wheel problem. And This one is more challenging, but it's the problems after that that apply to real life that you would use. So don't get too upset about this problem I'm going to do right now, but the ones that I do after that are ones that you would see on the final in pre-cal for sure. You would see them on the SAT, you would see them on the CASP. These are the problems after I do the Ferris wheel problem. These are the problems that they want you to know how to do for the standards. All right. So let's look on page 844. Okay, and I'm looking at the bottom of the page with the Ferris wheel. Okay, so we're going to use trig functions and a calculator to solve a problem. All right. You guys see that?
Yeah.
All right, a Ferris wheel with a diameter of 45 meters and 24 seats spread evenly around the outside of the wheel is stopped in the position shown in the diagram. Using the center of the Ferris wheel as the origin, what are the horizontal and vertical positions of seat 8? And then it says, how far above the bottom of the Ferris wheel is seat 8? And solve the problem using radians. Give answers to the nearest tenth of a meter. So the first thing I'm going to do is, having not really remembered what I read, I'm going to write down some information here. So the Ferris wheel, they said, is 45 meters. That's the diameter, right? And there's 24 seats outside the wheel. So the first thing we're going to do is we're going to find the angle between two adjacent seats. Adjacent means right next to each other. And we're going to find the angle between two adjacent seats. Now, they already said that we're working in radians, so put your calculator in radian mode immediately. So put the calculator in radian mode. So theta, a full revolution is 2 pi divided by 24. So the angle is going to be pi over 12. So that's the angle between two adjacent seats. Now we're going to look at the number of seats from seat 8 to seat 1. And this is pretty easy because we just take 8 minus 1, which is a range. And so that would be 7. So now we want to look at the rotation angle of seat 8. And what we're going to do with that is we're going to take 7 times the angle between the two seats, which is pi over 12. So that was your range, 7 times pi over 12. And we get an angle that's 7 pi over 12 radians. So from that, I'm going to find the x and y coordinates. So I'm going to take my x, what I know is that the ordered pair is r cosine theta and r sine of theta. And my coordinates are going to be r, which is 45 divided by 2. If the diameter is 45, the radius is 45 divided by 2 times cosine of 7 pi over 12. And the y coordinate would be 40r, which is 45 over 2, the radius, times sine of 7 pi over 12. So what we're going to do now, remember this is an ordered pair. We're going to take on the calculator, take 7 cosine of 7 pi over 12, and then multiply to 45 divided by 2 and tell me what you get. Cosine of 7 pi divided by 12.
I got negative
and enter.
5.82.
What, negative 5.8 about?
Yeah.
That's correct. And then what's sine of 7 pi over 12 times 45 divided by 2?
$21.7.
20. So let's write what we found. All right. Seat 8 is about 5.8 meters to the left. And 21.7 meters above the center of the wheel. So seat 8 is about 5.8 meters to the left and 21.7 meters above the center of the wheel. Also, the center is 22.5. So where is that number coming from? That's coming from half the diameter, right? 22.5 meters above the bottom of the wheel comma, so seat 8 is stopped. 44.2 meters above the bottom of the wheel. So where is this 44.2 coming from? It's coming from 22.5 plus the 21.7, 12, 44.2. So that's where it's coming from. It's coming from the radius plus above 21.7. Okay, now that we've jumped off the deep end now, let's take a look at a couple of problems that you're going to see frequently. I wanted to show you this problem though, because I want you to see the usefulness of trigonometry. Geometry was okay, but trigonometry is going to be way more useful, and you're going to see why right now. Take a look at page 845B. Now, I know Ms. Fresco in geometry always encouraged you to draw a picture. And in trigonometry, I'm going to be doing the same thing. You have to draw a picture. If you don't draw a picture, the problem's almost impossible to do. So make a note, you're going to always draw a picture. And let's read the problem. An airplane Now, I know you're all thinking, wow, she should not have been a math teacher. She should have been an art teacher. But don't hate, okay? Because I do realize that my talent artistically is just, you just can't even, you're probably just speechless about it, right?
You went into the wrong profession, Miss Birch.
What?
You went into the wrong profession, like you said.
I know. I should have been an artist. I know. I just, I just lost my, I lost my knack of what I really can do best, and that's art. All right. Okay, an airplane begins to descend downward toward a runway 1 mile away. Okay, now this plane does not just drop down. It descends down like this. So what's going to happen is we're going to draw a right triangle. All right, so an airplane begins to descend toward a runway 1 mile away at an angle of -5%. Now, when it says descends, we are talking about an angle of depression. And this right here is the angle of depression. It's not down below. So it's -5 degrees. And also, it also tips you up because it says from the horizontal. So that's how you know it's not this angle. So notice the reading. It says, an airplane begins to descend down toward a runway 1 mile away at an angle of -5 to the horizontal. So this is the horizontal, right? All right, what is its change in elevation? They're talking about this value, right? If I asked you to measure your height, you're not going to lean, right? So whenever you're measuring the height of something, you have to measure, somebody has to stand straight up and down. When you measure a tower, it's straight up and down. You're never measuring height on an angle. So in this problem, when they say height, this isn't height and that's not height. It can only be that one side. All right, so it says, what is the change in elevation after it flies 5,000 feet horizontally toward the runway? So this X is 5,000 feet. So we're trying to find Y. Well, can we use sine, cosine, or tangent? Well, I don't know. What do we have here? That's the angle. So don't we have opposite and adjacent? So what does that sound like? Opposite and adjacent. Remember your SOHCAHTOA?
Is it
Tangent is opposite over adjacent. So what we're going to do is we're going to take the tangent of -5 degrees, because that's the angle. Opposite is what we're trying to find, and adjacent is 5,000. So this is where the algebra comes in. We have to solve for Y. Well, how do you solve for Y? You multiply by 5,000, don't you? Yes, you do. So now we're going to put this in the calculator. Make sure you're in degree mode. And tell me what the height is. This should really be written like this. It should be written as tangent. It should be written like that. So it's tangent of -5 degrees times 5,000. And you don't need that degree symbol.
I got -437.44.
So the elevation drops by about 437.4 feet. Now notice I didn't put the negative because I'm using the word drops to mean negative. Did you hear what I said?
Yes.
The elevation drops by about 437.4 feet. Okay, let's do another one. Page 846B. I'm sorry, 8. How long a shadow does a 40-foot tree? So you have a tree. Now, do you guys typically see shadows in the air or on the ground? So it
On the ground?
says, how long a shadow does a 40-foot, so they're telling you that the tree is 40 feet. And it says cast on the ground if the sun is at an angle. So here's the sun. Is at an angle .5 radians relative to the horizontal. So are they talking about this angle or are they talking about that angle? Is this a horizontal or is that down there?
There.
So they want to know about the shadow, and they're saying that in relation to the horizontal, it's 0.5 radians, the angle. So over here, we had this in degree mode. Now we want radian mode. So it's switching back and forth. So look at your angle, and what do you have? You have adjacent and opposite again. So what trig function do you want to use?
10.
It equals opposite over hypotenuse, opposite over adjacent. SOHCAHTOA. So we have the tangent of 0.5 with radians. Make sure you're in the right mode. And opposite is going to be 40 over adjacent. Now, we are solving for x. This is a little bit more difficult. We're
What do
gonna,
40?
what's that? X multiply both sides by x,
Oh, yeah.
or set up a proportion. And now we're going to divide both sides by tangent of 0.5 to solve for x. You follow me or no? I multiply both sides by x, it goes away and I get that. Now divide both sides by tangent of 0.5. So what is 40 divided by tangent of 0.5?
$73.22.
About 73.2. So you would say the shadow is about 73.2 feet. All right, one more problem and we'll be done. Okay, I don't know where this is. I don't know where it is. I'm just going to write it out. A plane rises from takeoff and flies at an angle of 10 degrees with the horizontal runway. So these words like horizontal are helping you to draw the picture. Okay, so a plane rises from takeoff and flies at an angle of 10 degrees with a horizontal runway. When it has gained 500 feet, find the distance to the nearest foot the plane has flown. All right, so let me see if I can draw a picture here. A plane rises from takeoff and flies at an angle of 10 degrees. Okay, so the plane, this is the plane over here. But now it's over here. So it says a plane, right? Because a plane can't go straight up like a flying saucer, right? So a plane doesn't like rise up. So a plane has to gradually get up there. So it flies at an angle of 10 degrees from the horizontal. And they want to know when it's gained 500 feet. They want to know this now. Find the distance to the nearest foot the plane has flown. So this is the distance the plane has flown now. So we want to know the hypotenuse now. So we're going to need a different trig function. Tangent, opposite over adjacent isn't going to help. It's going to have to be one of the other ones.
Is it sine?
Sine is opposite over hypotenuse. And we do have opposite and hypotenuse, so that is correct. So make sure you're in degree mode now. Degree mode, sine of 10 degrees is equal to 500 over the hypotenuse. This time I'm going to use a proportion. Last time I multiplied both sides by c. This time I'm going to do a proportion. So this would be c sine of 10 degrees equals 500 times 1. We're solving for c, so we're going to divide both sides by sine of 10 degrees. So c is about what? To the nearest foot. So this is degree mode. Go ahead, I'm listening. What's 500 divided by sine of 10?
I got 2,879.38.
It's about, well, they say to the nearest foot. So about 2,879 feet. So you would say the plane has flown a distance of 2,879 feet. Now, we're not going to do this problem, but I just want to talk about it for a second. So the reason why trigonometry is more useful than geometry is because, let's say this is the lake. You don't have to get a string and measure the distance across the lake. If you know, like, if you know this angle and whether you know the hypotenuse or that, as long as you know what, like, and let's say this is the ground over here. Let's say you know this distance is like, say, 500 feet. You don't have to use a string to measure the length of the lake. All you need is an angle, and this measure, since you're on land, you can measure that distance. You can find the distance across the lake without even getting wet. So that's useful. Geometry was not that flexible. So now you can know the measurement angle, and you can know one of the sides, not two for the Pythagorean theorem. You can know one of the sides and know the distance across the lake, which is pretty useful. All right, now I was hoping that we would have time today to work on the practice AB, but what I want to do is I want to save that for Wednesday. So do not do the practice AB. We're going to do that in Math Wizard Teams on Wednesday in class. All right. So hopefully you're done with the unit circle quiz. And this lesson, you could be doing the book work and the online work, but do not do the practice AB. We'll do that on Wednesday in class. All right, that's all I have for today. Anybody want to ask me any questions? I did finish the lesson. So that is 17-2. Questions? All right. I hope you guys have a wonderful day. All right, and I'll see you Wednesday. All right, have a good day. Bye, guys.
Miss Birch, I wanted to let you know that I'm going to be taking my AP exam on Wednesday, so I'm not going to be here.
They're still doing AP exams?
Yeah.
Okay, all right, well, good luck. Which one is it?
English language.
Oh, wow. Okay, all right, well, good luck on that. Good luck on that AP exam.
Thank you. And I think some other students in this class are also taking it. Just
Yeah,
so you
they'll
know.
have to let me know because nobody has said anything to me. I didn't even know the AP testing was still going on.
Yeah, I think there's another admission going on. So yeah, I don't think it ends until June, but I'm not sure.
All right, okay, thanks for letting me know.
Okay, thank you, Miss Birch. Bye. Have a
Okay,
nice day.
bye, have a good day.